Right. So next on, we will discuss about chapter 5, chemical bonding. So this is one of the chapters that is considered quite simple. All right. As long as you follow the steps, all right, you do in a proper step by step, you should able to get a very good score for this entire chapter. All right. So these are some of the checklists that we need to know. All right. So first of all, we must be able to understand when to use ionic and covalent bond. We must able to predict the formula for the ionic and covalent compound. We need dot diagram. And we must be able to write the description for the bond formation. And in the end, we must be able to compare and explain the properties of ionic and covalent compound. So we try to go for all these objectives one by one. All right. So we will try to give a general idea. Then we will spend some time to do some questions on ionic bond. Then only we go into covalent bond. All right. I'll give you a simple idea first. All right. So first of all, we all have to understand what is the purpose to form chemical bond. Okay. So why we need to form chemical bond? There is always a reason behind. All the chemical substance, all the chemical elements, they form a chemical bond because they want to be stable. So we all must know what it means by stable from the standpoint of chemistry. In chemistry, stable means that the valence shell has already fully occupied. Okay, the valence shell has already fully occupied. So here you have to learn two words. If you only have one shell and the one shell is fully occupied with 2 electrons, you can call this as duplet arrangement. Okay, you can call this as duplet arrangement. Meanwhile, if you have more than one shell, you need 8 electrons in order to be stable. All right. So in this case, we call this as octet arrangement. Okay. So no matter duplet or octet, we will classify them as stable electron arrangement. Okay, so let's do a very quick recap. Okay, chemical substance need to form bonds with other purpose. They want to be stable. All right, so stable means that the outer shell is fully occupied. All right, so now we will go on a bit further. All right, so we have to understand this. All right, when you come to a chemical bond, there are 2 types of chemical bonds that we have to be very careful. The first chemical bond is called ionic bond. The second chemical bond is called covalent bond. All right, so we will discuss in detail about ionic and covalent bond in a short while. But for now, when you are getting two, when you should use ionic bond and when you should use covalent bond. All right. So one of the simplest way is that ionic bond is always formed by metal and non-metal. Meanwhile, covalent bond is always formed by non-metal joined with non-metal. All right. So by knowing your substance is metal or non-metal, we can predict what kind of bond they are forming. All right. So now the question is that how are we going to know who is metal or who is non-metal? So we all can refer to the periodic table. All right. This is a simplified sketching of periodic table. So everything from group 1 to group 13. Okay. If we are from group 1 to group 13, group 1 to group 13, all of them are metals. All right. Meanwhile, everything from group 14, everything from group 14 and onward. So group 14 all the way to group 18, they will be classified as non-metal. All right. So by referring to the periodic table, we should know that whether they are metal or they are non-metal. All right. So now we will try to work on some of the ideas how to do ionic and covalent bond. So we will begin with ionic bond. All right, you can do a few exercises, maybe 1 or 2 questions on the ionic bond, then only we go on with covalent bond. All right. So for ionic bond, all right, let's learn the ionic bond in very detailed manner. So for ionic bond, as what we discussed just now, we need a metal to join with non-metal. All right. Secondly, you must know in ionic bond what we do with electron. Ionic bond always involve transfer of electron. The word transfer here means that it involves the process of donate and also receive. Okay, so in ionic bond we need to donate electron as well as receive the electron. Okay, that is what we call transfer of electrons. Okay, all right. So the best way for us to learn is that we must know some strategy or some steps that what we can do. So this is the strategy for us to solve all the questions related with bonding. Okay, so this is the strategy for us to solve the chemical bonding question. So first of all, whenever we want to do a chemical bonding questions, first of all we need to write the electron arrangement. Okay, we always need to write the electron arrangement, okay, of the substance. All right, so we write the electron arrangements. All right, from the electron arrangement we can decide the groups, because this is something you learn in your chapter 4 periodic table. All right, so please remember the number of valence electron is deciding the group number. All right, so if we have electron is in group 1, if we have 2 valence electron is in group 2, if we have 3 valence electron, from 3 we have to plus number 10, it become group 13. 4 valence electron is group 14, 5 valence electron is group 15, 6 valence electron is group 16, 7 valence electron is group 17, and lastly 8 valence electron is group 18. So please remember, starting from 3 valence electron, we all have to add a number 10 to get the group number. So why we need to know the groups? Because we can actually use the group to know that it is metal or metal. So we can use the group to determine whether the substance is metal or non-metal. Do remember, metals belongs to group 1 all the way to 13. Non-metal is from group 14 all the way to group 18. All right, so this is how we do it. So after we know they are metal, we decide the bond. So we already be able to decide whether they will form ionic bond or they would form a covalent bond by knowing the nature of the substance to be metal or non-metal. Then we will start to predict the formula of our compound. Right? We must be able to predict the formula of the compounds. Must be able to know what is the formula when they join together. Then we begins with the cross diagram. So cross and dot diagram is a diagram to show how substance combine together. Is one of the most important thing in this entire chapter. All right. Then only in the end, after you draw the picture, you can try to write the word description. You can try to describe how the bond is actually formed. All right. So this is the flow. This is the strategy that we can use to solve whether ionic or covalent. This flow is workable. All right. So we will try to use some of the questions. All right, or we can use some example for demonstrations. Okay. So hopefully the example will give you some ideas what are we going to do and what we can do. So we will try to discuss 2 questions for ionic bond and 2 questions for covalent. All right, exercises together. All right. So first of all, we can try to do questions like this. Okay. So we can refer to the Alright, we can refer to the example number 1. Alright, let's say example number 1 give us two substance, which is substance A and substance B. Substance A, the number given to us is 23 and 11. Substance B, we are given 19 and 9. Let's start with this. Alright, so first of all, follow the flow. Alright, follow the flow. Step number 1 that we can see is that we have to write the electron arranged substance. So our A has 11 proton, therefore it has 11 electron, because when the substance is neutral, the number of proton is same as electron. So 11 electron will result in 2, 8, 1. Alright? So now we do the same thing for B. B has 9 proton. So when the B has 9 proton, it means that B also have 9 electrons. Okay? So when we have 9 electrons, the arrangement would be 2.7. So after we know the electron arrangement, we can refer to the valence electron, alright, to determine the group. So A has 1 valence electron, it is group 1. B has 7 electron, it's not group 7 but group 17, because starting from 3 valence electron we have to plus 10 in order to get the group number. So once we know the group, we can know that this substance is a metal or non-metal. So group 1 is a metal because group 1 to 13 part under metals. So group 14 to 18 is non-metal. So this substance B is group 17, so it is a non-metal. So once we know metal and non-metal, so we know that they will combine by ionic bond. So we know that they will combine by ionic bond. Alright? So for the ion, alright, we need to predict the formula of compound. Alright? Because not to say every time we have one A and one B combined together. Sometimes we might have 2A combined with 1B. Sometimes we might have a A combined with 2B. So we don't know. So we must predict the formula for compound. For ionic bond, to predict the formula for compound, we need to know the charge. Alright, we need to know the charge. Then only we can predict the formula of the compound. The problem is we don't have the charge in this question. The question don't charge. So if the question don't give us a charge, we need to predict the charge ourselves. I repeat, we need to predict the charge ourselves because we need to know the charge to predict the formula of the ionic compound. Right, so to know the charge, we just need to know a simple idea. Alright, so if we have a neutral atoms, so when we have an atom which is neutral, means it doesn't have charge. If a neutral atom go and donating its electron, right? If a neutral atom donates the electron, the neutral atom will become a positive ion, right? It becomes a positive ion. Meanwhile, when a neutral atom receive or gain electron, so when you receive electron, so it would become a negative ion. Alright, so this is a very important concept. So we will use this concept to predict the charge. So if you look back to our flow, alright, so I want to predict the charge of A and B first. So let's see. A has one outer electron. So when we have one valence electron, there are two ways for us to be stable. The first method is that we can throw the one electron become 2A, which is octet and stable. Or second method, we can take it to become 288, which is also octet and stable. While throw one electron seems easier than take in 7. Therefore, A will throw one electron away to be stable. And when A donated the electron, it becomes positive ion. A donate one electron, it becomes A plus. Okay, same thing goes for B. B has 7 outer electron. To be stable, B can choose to throw 7 electrons away to become duplex, which is the B also can choose to take one additional electron, become 2A, which is octet and stable. So receiving 1 electron seems to be easier than taking 7. Therefore, B will receive 1 electron, become stable. So when B receiving electron, okay, when B receiving electron, you become negative, alright? So it become a negative ion. So once we know the charge of the A and the B, we can predict the formula using the concept we learned in Form 4, Chapter 3. First of all, we list out the charge first, A minus. When the charge is the same, when we have similar charge, we just cut off the charge and join together. So we have A, B. So this is the formula. So now we know that we will have A, but 1A combined with one of the B. Simple as that. Alright, now after we predicted the formula, now we need to be able to draw a cross and dot diagram. This is one of the most important thing in this entire. How you draw the cross and dot diagram. So let me show you how you draw. So we can draw A first. So A, what you need to draw, look at the written formula here. So A, we have to draw 2A. 2A means that we have to draw 2 shells, or in the other word, 2 circles. So we draw 2 circles for A. Alright? So A have the electron arrangement of 2A. So the first circle is 2. The second circle we put 8. Alright? So that A is carry a charge of A plus. So when we have a charge, we have to draw a square bracket. We have to draw a square bracket and we put a plus at the top. Alright? So now we only need to draw one A because the formula tells us we only have a A. If this formula is A to B, so you have to draw 2 similar A. Alright? Depends on the formula. That's why it's very important for us to predict the formula, so only we know how many A and how many B we should draw. So now we should draw B. So B, what you should draw? 2 and 7. Alright? So we draw 2 and 7 first. So we draw 2 circles for the B. So we have to be careful with the symbol that we use for electron. If we use the cross symbol to represent the electron for A, to use the dot symbol. So we must be able to see the difference. Then only we can see the interactions of the electron, which I will demonstrate in a short while. So B is 2.7. So 1, 2, 3, 4, 5, 6, 7. And do remember the B is plus 1, receiving 1 electron. This electron that we receive must coming from the one who donate, which is the A. Alright, the A is the one who donate the electron and it go to the B. So when A donate electron, the electron of A is represent using a cross here. So now you can clearly see that these crosses looks different from the dot. So we clearly know that this electron is coming from this substance. Alright? So now the B has a charge of B minus. So for B minus, we just need to draw, whenever we have a charge, we draw a square bracket. We draw a square bracket with a charge on the top right corners. So this is how we draw a good cross and dot diagram. Alright? So it's not very hard. Most importantly, do step by step. Okay, we try to do one more example using this flow. Then only we try to explain and put all these things into words. Okay, so we try to do one more example first. So let's say we have another example. I call it example number 2. Let's say example number 2, we have a C and a D. So for C, the electron arrangement, let's say it is 7 and 3. Sorry. And then for D is 16 and 8. Alright? So let's try to do this whole thing using the similar flow that we learned before. Alright? So first of all, we must begin with writing the electron arrangement. Okay? So we do the same thing. So for C, we have 3 protons, therefore 3 electrons. For 3 electrons, the arrangement is 2.1. So when we have 1 outer electrons, then this substance belongs to group 1. And group 1, it is metal. For substance donkey, for substance D, we have 8 protons. So 8 proton equivalent to 8 electrons. So when we have 8 electrons, the arrangement would be 2.6. So we have 6 valence electron, therefore this substance D is parked under group 16, not group 6. Alright, because starting from 3 valence electron, we have to plus 10. So group 16 parked under non-metal. So when we have a metal and non-metal adjoining together, we know they will get ionic bond. Alright, so now we already know, okay, all the way until here, we already know what bond is it. Okay, so after we know the bond, we must predict the formula and draw the diagram. So let us predict the formula. As what I say, if we want to predict the formula for ionic compound, we need to know the charge. Alright, so we need to know the charge. So if we want to know the charge, we must look at what we have. So the whole question are not giving us any charge. So we have to try to figure out the charge ourselves. So if we want to get a charge, we must know whether the C and donkey will donate or receive the electron. Okay, so let's start with let's start with C. C has 1 outer electron. To be stable, donate 1 electron seems to be the easiest way. So when we donated 1 electron, alright, for the substance D, you have 6 outer electron. So the simplest way to be stable should be receiving 2 electron. Because if we want to throw the electron, we have to throw 6 electron, which is quite unlikely to occur. So when we receive 2 electron, we become 2A, which is octet and stable. Receiving electron will produce negative ion. So we receive 2 electron, it becomes 2 negative. So now once we know the charge of the C and D, we can predict the formula already. So the C is a C+, alright, the D. By referring to Form 4, Chapter 3, whenever we have ions with different charge, we can get the formula by using cross method. Okay, we can use a cross method to change the number, alright, by do a crossing. This is 1, it goes to the right. This is 2, it goes to the left. So we have C2 and D1, which we call C2D. So now we know that our final compound is made of 2C and 1. So now we need to go for a cross and dot diagram. Alright, so we draw a C2D. We have to be careful with this case. Just now we only have 2 atoms out there. Just now we only have A and B. So when we only have A and B, it's kind of easy. You draw 1 on the left, you draw 1 on the right. But whenever we have more than 1, like this, C2D, whereby we have 3 things. We have 2C and we have 1D. Alright? So when we have 3 or more than 2 things, we must put in a smaller quantity to be placed in the middle. I repeat, in this case we have C2D, we have 2C and 1D. Whenever we have more than 2 atoms, we have to put the 1 in a smaller quantity in the middle. So technically when you draw, you have to draw a donkey in the middle and surrounded by 2C. Okay? So now let's look at how we can draw. So for C we have to draw 2. 2 means that we only have 1 circle or 1 shell. So we put in 2 electrons. So do remember for the C, we have the charge of positive. Whenever we have charge, we must put a bracket with the charge on the top right corner. So we have 2C in this case, so we should draw the similar diagram on the right hand side as well. So we draw another circle, alright, same thing, we draw 2 electrons, and then we draw a square bracket and a plus on top here. So now we have 2C, alright. So now we can start to draw the D. Yeah? So look at the arrangement for D that we wrote just now. So for D, we have 2.6. So 2.6 give us 2 shells. We have 1 shell for 2, 1 shell for 6. So we draw 2 circles. Alright. So you cannot use the cross to represent the electron for D, because just now we already used the cross for the C. You have to use a dot so that you can see the difference of the electron, and you can also see who donating and who receiving electron in a more appropriate way. So the D is 2.6, so you draw 2 first, then you draw 6. 1, 2, 3, 4, 5, and 6. Alright, so the D is supposed to be plus 2, receive 2 electron. So when you receive electron, the electron must coming from the donor, which is the C. C donating the electron, now the D receiving 2. So when you receive electron from the C, C electron represent using the crosses. So you have put 2 crosses. So we know that 1 electron coming from here. And please don't forget our D carry a charge D2 minus. When we have a charge, we have to draw a square bracket and the charge to be put on the top right corner on top here, 2 minus. So this is how you draw a good diagram. So a very important reminder here is that you must make sure you follow all the flow, determine the bond, after understand the bond, predict the formula. Because if you don't go and predict the formula, we not even know how many atoms we should diagram. Okay, so once we able to draw the whole picture, it'll be a bit easier for us to do the last thing and the finishing steps, which is, alright, we should be able to write a good description. So to write a description, we just need to imagine we are writing a fairy tale. I repeat, if we want to explain the formations of the bond, which they normally ask in essay, to assume that we are writing a fairy tale, we just write out what's happening. So fairy tale, we can use a concept of this. We just introduce what is the prince in this fairy tale. We introduce the princess in this case. After that, you will see how the prince and princess meet up together. So we follow a flow like this. Alright, so I'll show you the exercises that we do a moment ago. Alright, let's go back to our first example that we discussed. So this is the first we discussed. Alright, this is the first example that we discussed. So we can try to turn this whole thing into some words. For example, we can start with A. Okay, you just need to write like this. A is 281 in the beginning. So you can write A, atom A has electron arrangement. So atom A has electron arrangement 281. So my prince has an electron arrangement 281. Prince has arrangement 281. What the prince will do to be stable? So the atom A will donate. Alright, you can write the word donate, you can write the word release, you also can write the word lose. How many? 1 electron. As you can see, you throw 1, so you will lose 1 electron. 2, alright, achieve stable electron arrangement. So you can write the word stable electron arrangement because that is the purpose why the substance need to donate or receive electron. They want to be stable. If you don't want to write stable electron arrangement, you are also, since after donate electron you become 2,8. 8 you also can call octet arrangement. So now after we become octet, so what happened here? When the A loses the electron, when A loses the electron, you will form A plus. Okay, anything got charge, anything with charge, when you write the name, you must write the word ion. So the ion A plus, right, is formed. So this is what you do. Okay, this is like how you introduce your prince. My prince is atom A1. Because it has 281, it will donate 1 electron. Why? Because it wants to be stable. So after donate 1 electron, what happened? A will become A plus. Okay? Alright. So we use exactly the same format or exactly the same template to go for the B. Alright? We do the same thing for the B. Yeah? Okay. So we can look at the atom B. So atom B initially is 2.7. Initial is 2.7. Alright. So atom B has electron. So the electron arrangement for the atom B is 2.7. Okay, so when you have 2.7, what atom B will do, as you can see from here, you are +1. +1 means you receive electron. So atom B will actually go over to receive, or you can write the word gain. If you don't like the word receive or gain, you also can write the word accept. Alright, atom B will receive, gain, or accept the electrons. Alright, how many? So you can see 1. So you receive 1 electrons. Why you want to receive 1 electron? Because you want to achieve stable electron arrangement. Alright, again, if you don't want to say stable electron arrangement, you also can write this. Because when you receive 1 electron, you become 2, 8. 8 means octet. You also can write octet arrangement. Okay? So after the B received electron, what happened to the atom B? Yes. So B minus has charge. Whenever we have charge, the name, write the words, the term ion. So the ion B minus is formed. Alright? So now we already understand what happened to the A and what happened to the B. So we already, if you look back to the format just now, I said when we try to do description, we describe in a fairy tale, we introduce the princess, which is the B. So at the end of the day, we need to tell people how the prince and princess combine together, how they meet up. Alright, so now let's think. So we have a positive ion and we have a negative ion. So we know opposite charge is attract, similar charge will repel. So when we have opposite charge between A and B, one is plus, one is minus, we know they will attract. So you write this, okay? So when the opposite charge attract, they will attract by a force. This force is force, okay? Any force of attraction between a positive ion and a negative ion is called electrostatic force. So you must mention how many A and how many B are attracting to each other. How are we going to know how many A or how many B are attracting to each other? So we can actually look at the diagram. Okay, we can actually look at the diagram. So if you look at the diagram just now, we have 1A and 1B. So 1A and 1B will attract to each other by this. When there's a plus and minus, there is a force that is called electrostatic force. So we can write like this, okay? 1A plus ion and also 1B minus ion. Alright? So they will be attracted to each other. So the ion attracted to each other by electrostatic force. Okay, so there's an electrostatic force that bind them together. Alright, so the force between the opposite charge ion is called electroionic compound. Okay, or they will form ionic bond. Alright, so when they form by ionic bond, at the end of the day they will form ionic compound. So you will get an ionic compound. What is the final formula for your ionic compound? As you can see just now, it's AB. So you write ionic compound formula AB is 4. So this is how you write a good answer. Alright, this is how you guys write a good answer. About A, which is the prince, introduce everything about B, which is, and tell people how the prince and princess join together. Alright, although the answer looks lengthy, but if you follow step by step, it's not that hard. Most importantly, you must begin with drawing a picture, because if you're able to draw the diagram of the bonding, alright, it will make the explanation much easier. Alright, our covalent, so for the second example that we discussed a moment ago. So this is the second example that just now we work on it, and this is the final pictures. So this is the final formula we have. Alright, so we will do the same thing for these entire questions. We'll try to do the same thing for this entire question. Okay, so this is the pictures that we drew a moment ago. Alright, so as usual, so how are we going to write it? we can begin the whole thing like this. Okay, so we can start with our C here. So our C initially has 2.1, so we just write this. Atom C has electron arrangement. So atom C has electron arrangement of 2.1. So when we have arrangement 2.1, what the C will do, as we can see over here, the C are going to donate electron. Okay, so atom C will donate. So donate how much? As we can see, is 1. So why atom C want to donate the electron? Atom C want to donate the electron because they want to be 2. 2 means that you duplet, or in the other word, you want to be stable. So atom C will donate 1 electrons to achieve stable electron arrangement. So in this case, if you don't want to write stable electron arrangement, you also can write duplet, because if we only have one circle and the circle got only 2 electrons, that is called duplet. Alright, so after the atom C donated electron, after the electron being donated, the C is become C plus. Alright, so C plus has charge. Anything has charge, when we write the names, we must write ion. Alright, C plus is actually formed. So this is how you introduce the atom C, which is our prince. So now we do the same thing to introduce our D, okay, our D. So for the D is the same. D initially is 2.6. So atom D has the electron arrangement. So atom D has electron arrangement which is 2.6. So when we have 6 electrons, so it's not stable yet, it's 2 electrons. So atom D will receive 2 electrons. So what is the purpose of receiving 2 electrons? Because atom D want to achieve stable electron arrangement. So once we achieve stable electron arrangement, so what happens next? Alright, so atom D, because we receive 2 electrons, you become D2 minus. So when you become ion, so you have to write this ion form. So now you already introduced your prince, which is the C, and you already introduced your princess, which is the D. Alright, so after we write the prince and princess, now is the time for us to put them together. Alright, so if we want to put them together, so we have to understand how many ions are combined together. This can be shown easily if we refer back to the diagram just now. As you can see, this diagram, we can clearly see that there are 2 C ion and 1 D2 minus ion. So we must write this, alright, 2 C positive ions and also 1 D2 minus ion. Alright, they are attracted to each other. So they will be attracted to each other. Alright, so what is the force that attract them? When we have a positive and negative charge, when we have opposite charge, we know there is a attractive force. That attractive force is called electrostatic force. So they are electrostatic force. So when we attracted by electrostatic force, alright, so we know that just now when metal combine non-metal, we're going to get ionic bond. So they will form ionic bond. Alright, so after they combine via ionic bond, this whole thing is called an ionic compound. So this ionic compound, the formula we predicted a moment ago, this is the one, C2D. So write the formula, C2D is formed. So this is how we write the answer. Okay, just tell people what happened to the C, tell people what happened, and tell people how the C and D are joining together. Alright, so although the answer is a bit lengthy, but as long as you follow the steps, you go step by step, you don't take shortcut, so by right it shouldn't be too hard to understand this. Okay, so now after we understand how ionic bond works, so now we can discuss a bit on how the covalent bond works. So covalent bond works in a very different way like the compared to the ionic bonds. It's quite different in terms of the mechanism. So let's look at covalent bond. Alright, covalent bond can be a bit trickier sometimes. So number one, we have to know covalent bond is formed by non-metal and also non-metal. So when we have non-metal adjoining with non-metal, so they will form a covalent bond. Alright, so the next thing is that we have to know what the covalent bond do with the electrons. So for ionic bond, they transfer the electron, which involve donate and also receive. Covalent bond, they are not going to donate the electron, they are not going to receive the electron, but instead they share the electron. Okay, so for covalent bond, they share the electron. Right, so here I'll have one concept to let you know. This is an additional side notes. When we want to share electrons, okay, if we want to share electron, we must always ensure it is fair. What it means by we must always ensure it is fair. If let's say one substance sharing one electron, another substance must also do the same, sharing one electron. If one substance sharing two electrons, another substance should also follow the same and sharing two electrons. Then only it would be fair. So this concept will be very important and very significant as we move on later. Alright, so we will follow the same flow. We will still using the same strategy to the ionic bond, because no matter ionic or covalent, the strategy to work on it are very similar. Alright, so now we will try to handpick two examples to discuss. Okay, we'll discuss about two examples over here. Alright, so the first example that we will discuss for covalent bond is this. Alright, so this is the first example. Okay, this is example number one. So let's say for example number one, we will try to do something like this. Okay, so we will do a substance. Let's say I call it as W. And W has a proton number 1 and 1. Alright. Meanwhile, the Y has a proton number, let's say we call it 16 and also 8. Alright. So let's try to work on these questions. Alright. Let's try to work on these questions and to see how this thing works. Alright. So first of all, as usual, we have to begin the question with writing their electron arrangement. W has the electron arrangement of 1. So when W has 1 electron, so we not even need to write electron arrangement. And I want you to know, whenever we see something that form or something that only has 1 electron, this substance is actually hydrogen. This W is actually a hydrogen. Any substance that only has 1 electron, it is actually hydrogen. So for hydrogen, we know that it is a non-metal. Okay, alright. So after that, we look at Y. So atom Y has 8 electrons. So we know the electron arrangement would be 2.6. When we have 2.6 as the electron arrangement, we have 6 outer electrons, so we have group 16. So group 16 is also another non-metal. So when we have a non-covalent bond, alright. So after we know what bond they form, as usual, we can predict what is the formula, right? We must be able to predict the formula of the compound. Because as what I say just now, if we can't even predict the formula of the compound, we will not able to know what are the diagram, what are the cross and dot diagram that we can draw. Okay, so guys, you have to be a bit careful here. The method for us to predict the formula for ionic compound and covalent compound is slightly different. For ionic compound, when we want to predict the formula, we need to know the charge. I repeat, For ionic compound, if we want to predict the formula, we need to know the charge, okay? Right? Just like what we did just now, okay? We need to know the charge, then only we can predict the formula, alright? Covalent compound, it's a bit special. For covalent compound, if we want to predict the formula, we do not need to know the charge. Alright, we don't need to know the charge. We still can predict the formula for covalent compound. So what we need, we write down the letter for the elements that want to combine, which is W and Y. So we have W and we have Y. Alright, on the top left corner, alright, on the top left corner, on the top right corner, we write down the amount of electron that we need in order for it to be stable. I repeat, on the top right corner here, we just write down the number of electron that it need to be stable. W has only one electron. If we only have one electron, we just need one more. We don't need 7, because for the first circle, 2 electrons is enough to make it full. That's why we have 1 already, we just need another 1 more. For the substance Y, it has 6 outer electrons. We need 2 more to make it become 8, which is octet. Alright? So after that, we can exchange the number. So the 1 goes to the opposite side, the 2 also goes to the opposite side. So we will have W2 and Y1. So we call it W2 and Y. So this is how we predict the formula for the. So do remember, the method to predict the formula for covalent bond is slightly different than the ionic bond. Because for covalent bond, when we predict the formula, we don't need to write out the charge. Alright? We just write out the number of electrons they needed in order to be stable. Okay. So after we predicted the formula, we need to come up with a cross and dot diagram so that we can know what is happening. Alright. So the way to draw covalent bond is a bit different than ionic. Okay, first our formula. Alright. So as you can see, our formula, we have W2Y. So we have total 3 atoms, which is 2W and 1Y. When you have more than 2 atoms, remember the one in a smaller quantity must place in the middle. So we have to put the Y in the middle and let the Y to be sandwiched in between 2W, alright? Because our formula is W2Y. So we need 2W and 1Y. Alright, when you come to covalent bond, our main focus is to share electron. So when we want to share electron, we need to show that there are some overlapping region. So we draw a circle like this, and then W also have a circle, and you must have some overlapping region. This overlapping means sharing. This W also have an overlapping region here. Okay, so what we need to do is quite simple. Alright, what we need to do is very simple. So we have no idea how many electrons that they should share. So sometimes we have no choice, but we have to do a try and error. So just assume that W is contributing 1 electron for sharing. When W dump in 1 electron for sharing, the Y has to follow and put in 1. Because remember, when we share the electron, it must be fair and square. So you share how many, I will share how many. So look at the W. So for W, we only has 1 electron. So when you put in 1 electron for sharing, outside here, nothing left. Alright? Do the same thing for this W. W will put 1 electron for sharing. Y also put 1 electron for sharing. Okay? So now, we will try to draw the outer electrons, because not all the electron put in for bonding. Huh? Right, as I said just now, W only has 1 electron. So when you only have 1 electron, the one and only electron you put in for sharing, outside here, nothing left. But look at the Y. In contrast, Y has 6 valence electron. We just focus on the valence electron we do, because when we form a bond, no matter we are donate, we are receive, or even we share the electron, we are playing with the outer electrons only. Alright, so we have 6 electrons here. So look at the Y. The Y contributing 1 electron to share here and contribute 1 electron to share here. Y has 6 valence electron, but as you can see from the picture, there's only 2 electrons involved in the bond. So which means that we have 4 more electrons which is not involved in bond. So we have 4 more electrons outside here. We can put 1, 2, 3 and 4. That's it. Okay, so this is how we draw the Y. Okay, so the Y here got 6 electrons. So 1, 2, 3, 4, 5, 6. Okay, the W has 1 electron and the W has 1 electron. So after you draw this diagram, you have to ask yourself, are they stable? So we look at them one by one. So we start with W. So W has 2 electrons with it, which is duplex. It is stable. Now we can look at our Y. So if you look at the Y in the middle, so the Y has 2, 4, 6 and 8 electrons. So when you have 8 electrons, which means that it is octet, which is also stable. Since the W is stable, the Y is stable, so this is the arrangement that we want. So after we ensure all of them are stable, please don't forget to draw the inner shell, because sometimes the atom might have more than 1 shells. Okay, so we start with W. W only has 1 electron, so you only have 1 shell, which is this. Alright, for the Y, Y has 2.6, so Y is supposed to have 2 shells or 2 circles. So we only draw 1 circle here, we should draw another 1 more circle inside. This circle inside, it's 2 electrons, so we put the 2 here. So this is the final pictures that we can draw. Okay, so again, step by step. Okay, so we will try to do another 1 more example. We try to put them into explanations again. Alright, so we try to do another one very famous questions in the examination. So one of the very famous questions in the examination is that, alright, you are given this. For example, you are given a carbon and oxygen. So this is our example number 2. Alright, so for carbon, you given number 12 and 6. Oxygen, you are given number 18 and 16 and 8. So all these number will be given, we don't need to memorize it. So as usual, we have to begin with determine the bond. To know the bond, we have to know metal or non-metal. To know metal or non-metal, we must know valence electrons. To know valence electron, we refer to electron arrangement. So we can do a bit faster. Carbon has 6 electron. Carbon is 2.4. Carbon has 4 valence electron. It belongs to group 14. It is a non-metal. Oxygen has 8 electrons. Alright, oxygen has 8 electrons. Oxygen has 2.6 electron arrangement. Oxygen has 6 valence electron, therefore it put under group 16. So when we have group 16, it is also a non-metal. So when we have a non-metal and non-metal, you know they will form a covalent bond. Alright, so after we bond that will form between carbon and oxygen, we must be able to predict their formula. Okay, we must be able to predict the formula. So this is a carbon and this is the oxygen. Do remember, for covalent bond, when we want to predict the formula, we no need to know the charge. Okay, so we no need to know the charge. Alright. For covalent bond, we just need to write down the amount of electron that we need in order to be stable. Alright, so carbon has 4 valence electron initially. So when you have 4, to be stable, you just need 4 more. You write the 4. Oxygen has 6 valence electron in the beginning. So for 6 valence electron to be stable, you need 2 more. So the number 4 and number 2 here, we exchange it. The 4 goes to the right and the 2 comes to the left. So theoretically, we should get C2 and O4. C2O4, this formula, whenever we realize the number, if the number can be simplified, we must simplify it. So we can simplify the whole thing by dividing a 2 on both sides. So if we divide 2 on the both sides, so we're going to get CO2. So once we know the formula is CO2, we should be able to draw it out. So again, if you want to draw this diagram, you have to be careful with the amount. We have CO2, we have 1C and 2O. Always remember, if we have like the C, which is lesser than the O, when we have a quantity which is lesser, the quantity which is lesser should be put in the middle. So the C should put in the middle and sandwiched by 2O. So we will draw something like this. So we will draw a C in the middle and then sandwiched by 2O. So do remember, we are drawing bond, covalent bond wanted to share electrons. So to share electron, we must draw a circle with some overlapping. Okay, we need to draw some overlapping to show that the electrons are being shared. As usual, when you come to covalent bonds, sometimes we have no idea how many electrons they should share. Okay, so if we have no idea how many electrons they should share, so we should try an error. We try one by one. We just try by sharing 1 electron in the first place. So let's assume the oxygen share 1 electron here and the carbon also share 1 electron here. Alright, same things. This oxygen also share 1 electron here and the carbon also share 1 electron over here. Alright, so now what we can do is this. Alright, so after we share 1 electron, which we don't know whether is correct or not, we should fill in all the remaining electrons. So how to know remaining electron? We just refer back to what we have just now. For example, carbon. I know carbon has 4 valence electron. So when I have 4 valence electron, I put 1 electron here for sharing, I put 1 electron here for sharing, I use up to 2 electron. So I have 4, I use 2, so I have 2 more electrons left. Alright, same thing go for the oxygen. Oxygen has 6 outer electrons. So as you can see, this oxygen only put in 1 electron for sharing. So when we put 1 electron for sharing, which means that we have 5 more electrons outside. So we put 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. Okay, now how to know this diagram is correct or not? So we must double check, we must ask ourselves, after they share 1 electron, are they stable? So we look at the oxygen. Oxygen currently has 2, 4, 6 and 7. You have 7, which is not yet stable. Stable, you need 8. Alright, now we look at another substance. We look at our carbon. Carbon in the middle has 2, 4, 6. So after carbon share the electron with oxygen, it only has 6 electrons, which means that it is not stable yet as well. So now, as we can see, after sharing 1 electrons, the carbon and the oxygen, both of them are not yet stable. So if both of them are not yet stable, which means that sharing 1 electron is insufficient. So we should try again by increasing the amount of electron they want to share. So let's redraw the diagram. But now we try to increase the sharing electron to become 2. So now I will let the carbon to share 2 electron and the oxygen also share 2 electron. So this carbon share 2 electron on the right hand side and the oxygen follow and share 2 electron as well. So as usual, we need to fill up the remaining electron here. So carbon, as we can see, has 4 outer electrons. So we already dumped in 2 electrons and 2 electrons. So all the 4 electrons for carbon is involved in sharing. So outside here, nothing left. So oxygen, we have 6 electrons, 6 valence electron. So the oxygen here, you put in 2 electrons for sharing, which means that outside here you still have 4. Outside here you still have 4. Alright? So now let's double check again, are they stable? So for oxygen, now after sharing 2 electrons, you have 2, 4, 6 and 8. So 8 is octet, which is stable. Let's do the same thing for carbon. Carbon, after you share 2 electrons with the oxygen, you have 2, 4 and 6, 8. So the carbon will get 8, which is also stable. So which means that now the carbon and oxygen both already stable, and this is the diagram that we want. So I hope you can see over here that when you come to covalent bond, sometimes it can be a bit tricky compared to ionic bond, because sometimes we don't know how many electrons they are shared. So we need to do try and error. Just try to share electron each of them and see whether they are stable after sharing 1 electron or not. If after sharing 1 electron they are not yet stable, the amount of electron to be shared, so then you will become then you double check again, is it stable? Alright? So after everything stable, please don't forget, one of the common mistakes for students is that a lot of students forget to draw all the inner shells. Carbon has 2.4, which means that carbon should have 2 circles, 2 shells. So we only draw 1 shell just now. So we should draw another 1 more shell inside and put in the 2 electron. Same thing go for oxygen. Oxygen is 2.6. So you should also have 2 circles or 2 shells. So here you only draw 1 circle, you need to draw 1 more and put in the electron. Okay, this is the diagram that we want. So no matter ionic bond or covalent bond, we must always go and draw the diagram, because only when you draw the diagram you know what is happening, and when you know what is happening, it is much easier for you to come up with the suitable explanation. Alright? So now we will try to do the last thing, because no matter ionic or covalent bond, we can see that after we draw the diagram, normally we need to know how to write a description. We must be able to change everything that we done into some words. Alright? So same thing, we will try to introduce the prince, which is one of the atoms, tell people everything what they do, and tell people something about princes, what they do, and how they join together. Alright? So we will use back the 2 examples we learned just now. Okay, we will use to discuss how it works. Alright, so for the first example that we have, alright, this is the first example. So let us try to transform this thing into a written words. Okay, we'll see how are we going to transform it into some written words, a written description. Alright, so we will use back the same 2 examples that we do a moment ago to transform them into the word descriptions. Alright, so now let's start. As we do the same thing like what we did for ionic bond, we introduce the prince and princess, we introduce the W and the Y. So let's do it. So W, alright, W has electron arrangement 1. Atom W has electron arrangement. So the electron arrangement is only 1. So when the atom W has the electron arrangement 1, so we know that atom W need, alright, 1 electrons in order to achieve stable electron arrangement. So you need 1 electrons to achieve stable electron arrangement. Alright, so now you won't become A plus, W plus, Y minus. No, because you are not donate or receive electrons. So you are not going to get any charge here. So now do the same thing for the Y. So the Y is 2.6. Atom Y has the electron arrangement 2.6. So electron you need, please learn to use the word need. Don't use the word donate, don't use the word receive. Use the word need. Atom Y need 2 electrons. So why you need 2 electrons? Same thing, to achieve stable electron arrangement. Okay, so now after you introduce the prince, the atom W, and the princess, atom Y, so now we can them together. Okay, for covalent bond, it can be a bit trickier. Okay, for covalent bond, it can be a bit trickier, which we have to be very, very careful. Okay. So for the covalent bond, this is the diagrams that we have. So I want you to learn how to write it in a proper way. All right. So I want you to learn the words called contributes. All right. So it's better for you to start from the middle, so it's easier. All right. So you have Y, so you can write this. One atom Y is actually contribute. One atom Y 1 and 2. So you contribute 2 electrons. You contribute the electron for what? You contribute the 2 electron to share. Okay, you want to contribute electron. You share these 2 electrons with what? 2W. Alright? With 2W atoms. Alright? So one of the atom Y contributing 1, contributing 2 electron. These 2 electrons share with 2W atoms. Alright? So when you share the electron, you know you will form covalent bond. So at here, I want to give you some extra side notes first. Okay, so I need you to know that for covalent bond, we have covalent bonds. Okay, we have 3 types of covalent bond that we have to be super careful when you look at the questions. If one substance share 1 electron, another one substance share also 1 electron, you share 1, I share 1, we can call this as a single bond. Alright, we can simplify this whole thing as a line. Alright, so when you share 2 and I also share 2, we can simplify it to be 2 lines. We call this as double bond or double covalent bond. So when one substance share 3 electrons, another substance 3 electrons, there's 3 lines. We call it as a triple bond. Alright, so you have to be very careful because in covalent bond it can go very, very specific. So at here we can see our picture. This is the Y and this is W and W. As you can see, here there is a dot and a cross, so you form a single bond here. Here you have a dot and a cross, you can form a single bond here. So there's total 2 single bond. You cannot call a double bond. Double bond happens when you have 2 lines come together at one time. But now you have 2, so we call this as 2 single bonds. Okay, so you write this. One atom Y contribute 2 electrons to share with 2W atom. Alright, after that 2 single covalent bonds are formed. Right, you form 2 single covalent bond. Okay, at the end of the day, when you form by covalent bond, this whole thing is called a covalent compound. So the formula for covalent compound, you can see from this picture, W to Y or to what you predicted just now. Okay, you also can look back to the formula that we have predicted, this one, W to Y. It's okay. So the final covalent compound, it's W to Y is formed. So just like what I say, although the answer looks like it's quite lengthy, but if you do follow the step, you do one by one, step by steps, it's not that hard. Alright? So I hope you get some. Most importantly, treat it like a story. Okay? You write what is W, what W arrangement, what W want to do to be stable. Then you do the same thing, you introduce your Y. What is the electron arrangement for Y, and Y need to do what in order to be stable. Then at the end of the day, you tell people, the prince and princess, how the W and Y combine together to form ionic or covalent bond, and then what is the final formula of this. So you have to do it in a very systematic manner. You have to follow step by step. Okay, it's better that you can follow step by step on what we do just now. It'll be better. All right. So we discussed another one more questions. This is example number 2 that we discussed a moment ago. So just now we actually already come up with all these prediction of formula. All right. We already come up with the predictions of formula, and also we have the diagram. Okay, we also have a diagram here. So same thing, let's see how are we going to write it in sum. So first of all, introduce the prints. Let's say C, just start with this. Alright, so atom C has, alright, electron arrangement. So the electron arrangement is 2.4. Alright, so after you write electron arrangement 2.4, remember covalent bond, you cannot write donate or receive. Okay, so you write the word need first. Okay, atom C need 4 electrons. So why you need the 4 electrons? So we need 4 electrons because we want to be stable. We want to achieve stable electron arrangement. So that's it. You become like C positive, C negative. No, you won't, because you only get the charge when you are donating or receiving electrons. So for atom C, you are not, okay, because we know covalent bond, you are not donating, you are not receiving, but you are sharing the electrons. All right, so now do the same thing and introduce your oxygen. Atom O, all right, has electron arrangement. So the electron arrangement of the atom O, as you can see, is 2.6. So when you have 2.6, so what happens is that you need to be stable. So atom O need 2 electrons in order to achieve stable electron arrangement. Okay, you need 2 more electrons to achieve stable electron arrangement. Okay, so now you already introduced the prints, you already introduced the princes. All right, so now at the end, they combine together. Covalent bond, when they combine, they need to share the electron. So to know how many electrons they share, the best thing is that we can refer to the diagram that we draw. Okay, so from this diagram, what we see, from this diagram, you can see a C and 2 O. So you can start from the middle, it's easy. So you can see how many C, there's 1. So you mention 1 C atom or 1 atom C, all right, would contribute, all right, contribute. How many electrons contribute by C? C is the crosser, so inside here got 2, so you contribute 4. So you contribute 4 electrons. These 4 electrons contribute for what? To share. You share, you contribute the 4 electrons to share. Share with this oxygen and this oxygen. So there are 2 oxygen here. So you share with 2 oxygen atoms. Alright? So the carbon contributing 2 and 2, 4 electrons. This 4 electrons is shared among 2 oxygen atoms. So now when you share the electrons, we know you form covalent bond. But please remember again, covalent bond can be a double bond, can also be a triple bond. So we must be very specific on that. Alright? So how are we going to be specific on that? So we look at this diagram. So we have a C, we have an O and an O. So remember, we have a 2 dot and 2 crosses come 1 shot. So that is a double bond. So over here, we have 2 dot and 2 crosses also. That is a double bond. So we all have 2 double bonds. Alright? So you cannot count 4 single bonds, because when 2 come together, this count as 1 double bond. It's not 2 single bonds. Okay? So we have 1 double bond here and 1 double bond here. We have 2. Alright? So 2 double covalent bonds. So 2 double covalent bonds are formed. Alright? So when we form 2 doubles covalent bonds, alright, at the end of the day, this whole thing is formed by covalent bond. So when you form by covalent bond, this whole substance is called covalent compound. So the final formula for covalent compound, you can count here yourself, which is CO2, or you can refer back to the one that is a CO2. Alright, so our final covalent compound, the formula CO2 is 4. So this is how we do the ionic bond as well as the covalent bond. Alright, so let's do a very quick recap. Okay, let's do a very quick recap. What is the important things that we learned so far in this chapter? Alright, so in this chapter we learned about bonding. Alright, the purpose of doing bonding is that they want to be stable. So we have two types of bond, which is ionic bond formed by metal and non-metal, covalent bond formed by non-metal. Whenever we given a questions, alright, whenever we given a questions, we must know exactly what are the steps to be done. Alright, so we have to write the electron arrangement for those substance. From the electron arrangement, we refer to the valence electron, we decide the group. The group will tell us they are metal or non-metal. Once we know we have metal or metal, we will know whether we will form ionic bond. Alright, so then we predict the formula of the compounds that we are getting. Alright, then we go to draw the cross and dot diagram. Okay, do remember the cross and dot diagram for ionic bond and covalent bond are a big difference. In ionic bond, you're going to see some square bracket like this. Okay, you're going to see some square bracket, you're going to see some charges, see like they have some overlapping in between the shells. But when you come to covalent bond, they need to share the electron, so you will see there has overlapping. So there's overlapping region. This overlapping is the sharing region, and covalent bond you don't see any charges. Alright? Then after you draw a good diagram, you can transform the whole thing and write a good words description. Okay, just describe the first atom, tell everything about the atoms, and at the end of the day, you have to describe how these two atoms are and join with each and others. Alright, so hopefully you get some ideas how to solve this kind of questions. Alright, it's not to say very hard. So we can refer to the exercise booklet. We can look at the exercise booklet to get some ideas. Alright, for me, as long as you're able to draw the diagram, too hard. Alright, let us try to use one for demo. So look at the exercise booklet, turn on to page 20. This is the exercise booklet that you can find out in page 20. Alright, so by right, we already able to understand what is ionic bond, what is covalent bond. We're able to predict the formula of ionic and covalent compound. We're able to draw the diagram, where we're able to write a good description for them. Alright, let's use this question for demonstration. So we have P, Q and R. Okay, so this is a question came up. Question say that P, Q and R is react to form two compounds. They have different bonds. So you know that two of them will form ionic, two of them will form covalent. Use the information, you have to explain how you form the two compounds. So you are given 10 marks. Okay, so which means that you can expect 5 marks go for ionic, 5 marks go for covalent. Okay, so first of all, you should write the electron arrangement first. Okay, so for P has 19, which is 2881. So when you have one valence electron, you are metal. For Q, you have total 8 electrons, so which is 2.6. So when you have 2.6, so you have 6 valence electron, technically you should be non-metal. Same thing go for R. So for R, we have total 6 electrons here. Okay, R we have 6 electrons on top, so we should have 2, 4. So when we have 4 valence electron, it also a non-metal. So now we can handpick some of them to form covalent bond. So ionic bond, we need a metal and a non-metal. So we have two non-metal here. How to know which one we should choose? So if we want to do ionic bond, we want a substance to donate and a substance to receive electron. Obviously, the metal will be the one to donate electrons. So if you have one electron, donate electron, it's very easy. So we need the non-metal to receive electron. So now how to choose among them to choose the best one to form the ionic bond? So we think, if we have Q, we have 6 valence electron, we need to receive 2. But if we have 4 valence electron, if you want to receive, you have to receive 4. Receive 2 electrons seems to be easier compared to receive 4. So I think this one should be much appropriate. So I will choose this and this to form my ionic bond. For covalent bond, should be these two non-metal, which is this and this. Alright? So now I already know and I already be able to choose them to form the ionic and covalent bond. Go back our flow. So once you know what bond they form, you should go and predict their formula. So let's do it. So I will try to predict the formula for the ionic bond and covalent. So ionic bond, I know it will form between P and Q. To form ionic bond, I know I need to know the charge. So P has 1 valence electron. So I think if P got 1 valence electron, it will more likely to throw the 1 valence. So for the Q, it has 6 valence electron. I think it will receive 2 more electron to become stable. When you receive 2 electron, become Q2 minus. So when we have a P plus and a Q2 minus, so we can predict the formula by exchange the number. The 1 go to the right, the 2 goes to the left. So the formula should be P2Q. Alright? So this is how we predict the formula for the ionic bond. Okay? So we can try the same, we can start to work on the ionic bond. So for ionic bond, we can draw the diagram. Remember, if you only have 2 atoms here, for example, 1 P and 1 Q, you just need to draw 2 atoms left and right next to each other. But in this case, we have P2Q, means that we have 2P and 1Q. So when we have more than 2 atoms, we must always put the atoms in a smaller quantity in the middle. So try to put the Q in the middle. Alright, the side. Okay, now let's draw the picture. So now we are trying to draw the ionic bond. So for ionic bond, alright, we refer back to this thing. So for the P, we have to draw 2, 8, 8, which is 3 circles. Okay, so we draw 3 circles. 1, 2, 3. So this is 2, this is 8, and this is 8. Do remember the P has the charge of positive. So when you have the charge, you have to draw a square bracket and put the charge on. So we have 2P here. So this P, we draw exactly the same diagram as this. So we just draw the P here. Okay. So after we draw the P, so now we can draw the Q. For the Q, we have 2, 6 originally. So we should have 2 and 6, and afterward we add 2 extra electrons. These 2 extra electrons must use different symbol because they are received from other people. Which is 2 circles, 2 shelves. So the Q here, we draw 2 circles. Just now we use crosses to represent electron for P. So the Q, we cannot use the same symbol. We have to use a dot. 1, 2, 1, 2, 3, 4, 5, and 6. So when we have 6 electrons, we know the Q just now will receive 2 electrons. So these 2 electrons received from other people, so we have to use other symbol, put 2 crosses. So we know these 2 electrons coming from other place. So when we receive electron, the Q is becoming Q minus, Q2 minus. So when you have charge, please draw square bracket. And then the charge put on the top right corner. So this is how you draw the diagram for the ionic bond. So once you're able to do this, you should be able to do the description in a very, very easy way. For example, let's say I just mentioned it verbally. We can write this. Atom P has electron arrangement 2881. Atom P will electrons to achieve stable electron arrangement. Plus ion is formed. P plus ion is formed. Okay, Q atoms has electron arrangement 2.6. Alright, Q atoms have electron arrangement 2.6. Q atom will receive 2 electron to achieve stable electron arrangement. Q atoms will receive 2 electron to achieve stable electron arrangement. So when 2 electron, what happen? Ion, Q2 minus, ion, Q2 minus is produces. So after you introduce the prince P and the princes Q, you must tell people how they join together. Remember, in ionic bonds, we have ions, we have charge. So the opposite charge can attract together. So 2P plus ion, 2P plus ion, Q2 minus ion, they will be attracted to each and other by electrostatic force. Remember, the force between plus and minus is called electrostatic force. Okay? 2P plus ion and 1 Q2 minus ion will be attracted to each other by electrostatic force. So when they combine, they will form ionic bond. So ionic bond, we don't need to specify single bond, double bond, triple bond. Only covalent bond we need to do so. Alright? Then at the end of the day, when they combine by ion, then they form ionic compound. So the ionic compound, your final formula is 1P, 2P, P, 2Q is formed. So this is what you need to know. Alright? It's not very, very hard. You just need to know how to do it in a very systematic manner. Okay? We will discuss another one more. Okay? Questions? Alright? Same thing from the same page just now. Page number 20. Alright? So we already worked on the ionic bond. Now we covalent bond as well. So for the covalent bond, so we know that between these two non-metal, Q and R. So let's do it. So we need to predict the formula as well for the covalent bond. This covalent bond is actually formed between Q and R, okay? Because they are non-metal. Okay, so how we predict formula for covalent bond? If you remember, covalent bond to predict, no need to know the charge. Okay, we don't need to know covalent bond. We just need to write down how many electrons we needed in order to be stable. So the Q here has total 6 electrons. To be stable, you need 2 more. The R here has 4 electrons. To be stable, you need 4 more. Alright? So now, if you want to work on these questions, okay, if you want to work on this question, so we just need to exchange the 4 comes here, and then the 2 comes here. Alright? 4 goes here, and then we can then do the simplification. We can simplify, so we have Q4R2. If we simplify, we can divide 2 on both sides, we can get Q2R. You can write Q2R or you can write RQ2. It's okay. Alright? So when you draw the pictures, as usual, so covalent bond, most importantly, you must show the circle is overlapping. Because if the circle is not overlapping, you cannot show the sharing of electrons. So we have 1 R and 2 Q. We have 3 atoms. When we have more than two atoms, we have to put the one in a smaller quantity in the middle. So we put R in the middle, sandwiched by 2Q on the side. And then we do the same thing. We try to share 1 electron first. So if we try to share 1 electron here for the Q share 1 electron, the R will also share 1. The Q share 1 electron, the R also share 1. So we fill in all the remaining electron. If you look back to just now, so the Q has 6 outer electrons. The Q now only got 1. So you have 5 more outside. 1, 2, 3, 4, 5. Alright? So 1, 2, 3, 4, 5. So the R has 4 outer electrons. So to be stable, so R has 4 outer electrons. You only use 2 here, 1 here and 1 here. So which means you have 2 more outside. So how to know sharing 1 electron it's okay or not? So we just check in the end, are they stable? So the Q in the end only has 6 and 7, which is not yet stable. The R in the end is 2, 4, 6, also not yet stable. So in this case, what you need to do is that if sharing 1 electron is not yet stable, you need to increase the amount of electron for sharing. So the Q will put in 1 more electron for sharing. The R will also follow the same thing, because remember, when it comes to sharing electron, it must be fair and square. If the Q is contributing 2 electrons for sharing, the R must also do the similar thing as well. Okay, so same thing go for here. This Q also dump in 1 more electron for sharing, 6, 8, which is what we want. The Q here also 2, 4, 6, 8, which is what we want. Alright, so the description is exactly same like what we learned just now. Alright, so we can just mention, alright, verbally. Okay, we can just mention the Q and R, just mention atom Q has electron arrangement 2.6. Atom Q need 2 electron to achieve stable electron arrangement. Atom R has E.4. Atom R need 4 electron to achieve stable electron arrangement. Okay, so after you introduce the prince and princess Q and R, you have to tell people how they combine. Okay, here look at the picture. 1 atom R contributes 4 electron to be shared with 2 Q atoms. 1 atom R contribute 4 electrons to be shared with 2 Q atoms. Alright? So now when you share bond, you form covalent bond. So 2.2 crosses, this is a double bond. 2.2 crosses, this is a double bond. So 2 double bonds are formed. 2 double bonds are formed. Then at the end of the day, since you form by double bond, so since you form by covalent bond, you must mention covalent compound for this whole thing, Q2R or RQ2, it's formed. Okay, so if you fully understand how to work out the covalent bond and also ionic bond, you understand the flow, you're able to do step by step, it shouldn't be that hard. Alright, big questions for ionic and covalent bond, the pattern of the questions are very predictable. Okay, very predictable. And normally these questions are being tested in essay and the reward was pretty good. Normally we are talking about 8 to 10 marks. Okay, so they're going to give you a very good score when you come to this. Okay, so for the last part of the chapter 5, chemical bonding, so now we will compare some of the properties of ionic compounds and also covalent compound. Alright, so first of all, let's make it in a simple table so that it's easier to do comparison. So we have ionic compound and covalent compound. The first thing is that we can compare they are made of what, right? Ionic compound is made from metals in combined with non-metal, right? Covalent compound is made from non-metal joining with non-metal. Alright, so this is some things that we learn. Alright, after that we have to know what they do with electrons. Alright, ionic compound transfer their electron. When I say transfer, it involves the word donates and also it also include receive. Meanwhile, covalent compound, they share their electrons. Alright, so that's the second thing. Okay, So these two is the basics comparisons that we learn for ionic and covalent compound. Right now we will get into a bit more detail. The next thing is that we have to know what are the states of matter. Alright, at room temperature. Do remember, room temperature is 25 degrees Celsius. Ionic compound at room condition, it's always appear as a solid. Covalent compound at room temperature, they might be liquid as well as gas. Alright, so the three possibility. Okay, so now we have subsequent three more comparison, which is super important, very significant. Alright, so next thing we have to learn is called solubility. Alright, so when it comes to solubility, alright, we are talking whether this substance is soluble or not. Alright, so I want you to know that if we want to dissolve a solid, there are two possible solvents. Alright, there are two to dissolve a solid. Alright, so first of all, I want you to understand what it means by the solubility. Alright, so if you take a solute is actually the solid to be dissolved. You're going to add on with a solvent. Solvent is actually liquid in order to dissolve the solids. Alright, so if a solid plus the solvent, you're going to get a thing called solution. Right, solution is the final liquid outcome. A simple example, we can take a solid salts. You add in some water, the water is a solvent. Of the solid salts, you're going to get a liquid salt solution. Alright, so that's what we need to know. Right, in general, we have so many solvents out there, but for your information, solvent can be classified into two big families. The first one is water, the second one is organic solvent. Alright, organic solvents are some special solvent that they can dissolve some things that water couldn't. Alright, normally the organic solvent will have some quite long and weird names. Example, we have tetrachloromethane. Okay, we might have benzene, which you don't need to memorize all of them. For Form 4, one of the simplest organic solvent that you can remember is ethanol. Alright, ethanol. This is one of the simplest organic solvent that you should know. Alright, so now come back to our study now. Alright, when it comes to solubility, you must know the solubility in water and also the solubility in organic solvent. Alright, solubility in the water and the solubility in the organic solvent. So for ionic compound, they are soluble in water, but they are not soluble in organic solvent. Covalent compound, everything go opposite. They are insoluble in water and they are soluble in organic solvent. So this is very important. So if the question gives you one unknown substance, they say this is a substance W, it's soluble in water, it doesn't soluble in organic solvent. So from this particular description, you should have some rough idea that they are actually talking. Alright, so this comparison is very important. Okay, so all the 4 points in this particular table, we just need to be able to see the differences, and we don't need to know how to explain yet. Alright, we don't need to know how to explain all these differences for these 4 different points. Alright, now we have 2 more comparison left, and these 2 comparison is very important and very significant, because for the subsequent, not only need to be able to compare, we must also be able to provide explanation. Alright, so let's go. So now this is the extension from the table. It's the same table like just now, it's not a new table. Alright, so this is ionic and this is covalent compound. Right, so the first thing that we need to study is this. Alright, melting and also boiling point. So this is very important. Okay, this melting and boiling point, I'm going to put a star here. So anything I put a star means it's very important, and this thing we need to be able to explain. Okay, so ionic compound has a very high melting point, and boiling point, covalent compound has a relatively low melting and boiling point. Okay, this is very important. We must be able to know how to explain. Right now, I'll show you some simple ideas when you want to explain about melting and boiling point. Alright, so when we want to melt or when we want to boil a substance, alright, when we want to melt or when we want to boil a substance, alright, we all need to overcome some of the force of attraction. Okay, there's some of the force of attraction we need to overcome. Example, this is the solid. So the solid was like closely packed together. So all the solid here, there are some forces that are holding them together. So if you want to make them become liquid, okay, if you want them to become liquid, so we need to break some of the force. Only when you break some of the force, you will get some cluster of liquid like this. Same thing goes on. If you want to become gas, you have to break and overcome some of the forces, then only they can become a gas like this. Okay, so the key is that when you want to melt or when you want to boil substance, we need to overcome force of attraction. Okay, so any questions that actually asking us, any question that asking us to explain, if we have any question that asking us to explain melting and boiling point, if there's any question ask us to explain and melting and boiling point, our answer should always include a few things. First of all, our answer should go in and include the force of attraction. So it's better for us to include the force of attraction. We tell people the name of the force, alright, and also the strength of the force. What is the name of the force and what is the strength of the force that we need to overcome. After that, we must tell people how much heat that is needed, how much heat we needed in order to overcome the force of attraction. Okay, so all the questions related with melting and boiling point, we always can play with these two things, alright, force and heat. Alright, so now if we go back to something we learned a moment ago, we now has a high melting point and then covalent compound has a low melting or boiling point. So we must know that how are we going to explain it. So first of all, we must know the force. Ionic compound has positive ion and negative ion. I'll use sodium chloride for demonstration. So when there is opposite charge, alright, there is a force in between them, which we learned a moment ago. Alright, when there is a charge between opposite charge, okay, so when there is a force between opposite charge, there is a force. This force is called electro force. Okay, this force is called electrostatic force. So electrostatic force is a very strong force, okay, which makes sense because the force is very strong. You need so many heat to overcome it. So when you need many heat, that's why the temperature to melt or boil is high. Alright, so how to put it in words? So you can mention like this, okay, in the ionic compound, when we have ionic compound, all these things got charged, we call it ions. Alright, all acted by very strong electrostatic force. Okay, so they are attracted by very strong electrostatic force. So when they attracted by very strong electrostatic force, therefore, okay, a lot of heat, alright, you need a lot of heat is needed or required to overcome the force of attraction. Okay, so this is how you explain something regarding your ionic compound. I mean, when you come to melting and boiling point. Alright, so if you go back to the flow that we learned just now, you see it exactly follow the format, as in the question got mentioned about the name, which is called electrostatic force, the strength, which is strong, and then the heat, which is a lot. Okay, this is the first one. So for ionic compound, so this is the reason the boiling point was pretty high. Okay, now when it comes to covalent compound, I need you to be a bit careful, alright, and I'll explain what is it. So for covalent compound, let's say we know covalent compound is something made from non-metal and non-metal, let's say carbon dioxide, and carbon dioxide. So all these are covalent compounds, so they make by non-metal and non-metal. So for covalent, it's here, alright. So the force that you need to overcome when you come to covalent compound is actually called van der Waals force. Okay, you can call it as van der Waals force. Van der Waals force also can be written as intermolecular force, which makes sense because anything made from non-metal and non-metal you learn in Form 4 Chapter 2. In Form 4 Chapter 2, anything made by non-metal and non-metal covalent compound, you also can call it as a molecules. Between molecules, the force in between them is called intermolecular force. Alright? So many people when they come to covalent bond, they go to break the wrong one. Many people when they come to covalent compound, they go to break the covalent bond in here, which is wrong. You cannot break the covalent bond because covalent bond is the bond inside the CO2. It's the bond. So when we want to melt or boil something, you are not breaking the bond in, you are breaking the force in between the molecules, which is the van der Waals. So you have to be very, very careful. Okay, so please be reminded, if you want to melt or boil ionic compound, the force to be overcome is electrostatic force. If you want to melt or boil covalent compound, the force to be overcome is van der Waals forces, or we call it as intermolecular, is weak. Alright, so we have a very weak intermolecular forces. That's why we don't need a lot of heat to break it up. So that's why the melting and boiling point is low. Again, let's see how are we going to write it. How are we going to transform this whole thing into a good description? Okay, you can write this. In covalent compound, alright, so all these substances, they are called molecules, alright. This one got charged, you call it ion. For the molecules, they are attracted by a force. The force is called van der Waals, which is very weak. So we have weak van der Waals force. Alright, remember, if you don't like to use the word van der Waals force, the alternative words you can use is called intermolecular force. Alright, so when the molecules attract by very weak van der Waals forces, alright, very little heat, only, okay, I should write this in red color so we get alert. Only little heat it's needed or required. You only need very little heat, okay, to overcome the force of attraction. Okay, so you can see you still follow the same format like what I mentioned. Alright, if you want to explain about melting and covalent compound, the name of the force you need to overcome is called van der Waals, or we call intermolecular forces. The strength is very weak. So because you have a weak forces, you need little heat to overcome it. So this is what you need to know when you come to the explaining the melting and boiling point for ionic compound as well as covalent compound. Alright, this thing will be always tested in the essay questions. Alright, normal that they will set a questions which is about 15 to 20 marks. They will ask you to explain the formation of ionic bond, the formation of covalent bond, drawing the cross and dot diagram, just like what we did just now. Alright, okay, another extra 10 marks, they will ask you to compare the properties between the ionic and covalent compound. Normally they will ask you to compare the melting and boiling point coupled with, alright. So apart from comparing melting and boiling, there is another one more possible comparison that we need to know, and it's also very important to explain it. Okay, so now we'll look at the last thing for this entire chapter. So the last comparison for this chapter is this. So this is ionic compound and this is covalent compound as well. So the last thing that we need to know is that we need to know how to compare their electric conductivity, whether they're able to conduct electricity or not. Alright, so ionic compound, alright, it's very special. Ionic compound can conduct electricity, but in very specific condition. In two conditions. The first condition called molten, the second condition is called aqueous. Alright, so ionic compound can conduct electricity in two conditions. One is called molten, one is called aqueous. Alright, so first of all, you have to understand what is molten and what is aqueous. This concept you will relearn again in your Form 4 Chapter 6 Electrochemistry. Important. Alright, so what is the difference between molten and aqueous? When you come from PD3, okay, you learn about solids, you learn about liquid, you learn about gases. So these are the three states that we learn in PD3. But when you comes to the SPM, alright, or even IGCSE, so we need to know that the liquids can be classified into two possible things, which is called molten as well as aqueous. Alright, so molten and aqueous, both of them, they are liquid. Both are liquids. The only difference is how are you going to prepare or making the liquids. Molten also related with the word melted. So if you take a solid, you heat it up to reach its melting point, the solid melted and you got some liquid, so that liquid is called molten. So for aqueous, it's a bit different. For aqueous, you take some solid, but now you're not going to melt it, you're not going to heat it, you're just going to dissolve it in water. So when you dissolve it in water, you still get a liquid in the end as a final product. The liquid is called aqueous. Alright, so do remember, molten and aqueous, both of them, they are liquids. They only different in a way that how are you going to prepare or making the liquids. That is the big difference. Okay, so now we will go on to the next one. We will try to come back to here. Okay, we finish a comparison first, then only we come for explanation. This is also very important because we need to explain. Covalent compound cannot or unable, alright, covalent compound unable to conduct electricity. Okay, covalent compound cannot conduct electricity in any condition, no matter solid, liquid, molten, aqueous, gas. Covalent compound cannot conduct electricity at all. Alright, so now we must be able to express electric conductivity. So same thing. Now let me show you one important strategy like just now. Alright, so as what we learned a moment ago, when it comes to melting and boiling point, your answer must talk about force and heat. Okay, force and heat. Okay, now when you come to electric conductivity, okay, when you come to electric conductivity, I need you to understand the idea for electric conductivity. Alright, if we want to carry an electric from one point to another point, this is the one. This is the point A. Alright, this is point A and this is point B. So if you want to carry the electric or electricity from one point to the other point, you need somebody to carry the charge for you. Alright, if you want to carry from point A to point B, you need somebody to carry the charge for you. Alright, so just imagine, let's put it in this way. Alright, you want to send a letter. Alright, you want to send a hard copy letter. Alright, if you want to send from point A to point B, you need somebody to help you to carry the letter for you. Alright, so you might need a postman. Okay, so we need a postman. So this postman will carry the letter and move from point A to point B. Alright, so postman a letter for me. Now we try to marry this concept with chemistry. So I want you to change this letter become electric or become charge. Okay, So now we don't want to carry the latter, but we want to carry the charge or electric from one point to the other point. So when you want to carry the charge from one point to the other point, you need a postman. This postman we call charge carrier. We call it charge carrier. Alright, so there are two charge carrier that we need to know. Alright, so for SPM, especially for these topics, the important charge carrier that you must know is called free moving ions. So we need some free moving ions. Okay, so this free moving ion is the postman. This postman free to move and carry the electric for us. Alright, so now we will try. So all the questions, okay, all the questions that ask us to explain electric conductivity. So as long as the question asks us to explain electric conductivity, the strategy is that we must go and talk about free moving ions. Simple as that. So for example, if the compound A can conduct electricity, your answer can be simple and straightforward. Compound A has or contain free moving ions. Why compound B cannot conduct electricity? Because compound B doesn't contain free moving ions. So it's very straightforward. Okay, it's very straightforward. If you can conduct electricity, free moving ions should be there. If you cannot conduct electricity, means you don't have any free moving ions. Okay, now we will put it back into the table just now, and we will see how come it makes sense. Alright, so ionic compound can be provided in molten and aqueous, because in molten and aqueous they are free moving ion. Okay, so you have free moving ions when you come to the molten and aqueous. It makes sense because, alright, let's say, how come ionic compound they never mention solid? Solid cannot conduct electricity. Okay, solid cannot conduct. Why? Because in solid form, all the ions, the plus and minus, all the ions, they are attracted by the force, which we learned a moment ago. So if you all remember, this force is called static force. Okay, so when there is a force that holding all the ion is tied up, is holding by the force, so all the ions are unable to move freely. Just imagine that there's a rope that tie you up. So when the rope tie you up, you can't move freely. So that's why you cannot conduct electricity. So in solid form, all the ions are tied up. They are attracted by electrostatic force, and that's why they cannot move freely. That's why you couldn't conduct electricity in solid form. Aqueous is another story. Molten and aqueous, alright, it's when they become liquid. We know when you want to change solid become liquid, you have to overcome the force of attraction. So when this force is being overcome, when this force is not existed, so all the ions are not tied up by any force here. So when the ions are not tied up by any force, all these ions are able to move freely. When the ion can move freely, they will become the postman that can help you to carry the charge from one point to the other point. And that's the reason why we city. Okay, now for covalent compound, how come it cannot conduct electricity at all in any particular condition? Right, of course the simple answer, we know that, alright, if you cannot conduct means that you don't have any free moving ions. Simple as that. Okay, because think about electric conductivity, think about free moving ions, think about melting and boiling point, think about forces and heat. Alright, so now we can go in deep why covalent compound don't have any free moving ion. A basic covalent compound for demonstrations, let's say we have a CH4 called methane. So CH4 is methane. It is made from non-metal carbon and non-metal hydrogen, which you all know it is a covalent compound. Okay, it is a covalent compound because non-metal adjoining with non-metal. Alright, so remember just now what is the concept we learned. If you want to conduct electricity, you need a postman. This postman is called free moving ions. So free moving ions 2, which is something that got charged. Okay, anything got charged, that only called ions. Now if you look at your covalent compound, for covalent compound there's no charge at all, so there's not even an ion. You not even have ion at all. Alright, you have no ion at all because you don't have charge. So for covalent compound, all of them, they only have all these no charge, or what we call neutral molecules. So all these neutral molecules, they couldn't carry electricity for us, because again, to conduct electricity, we need somebody got charge, which is ion, and they must be able to move freely. Okay, so now you can write in this way. So covalent compound cannot conduct electricity because there are no free moving ion, because all the covalent compound is made of or consists some neutral molecules. Alright, these charged molecules. So when we have neutral molecules, you don't have free moving ion. Okay, you don't have free moving ion in order to carry the electricity. You can call it electricity, or some books call it as current also can. Okay, so this is what you need to know. So let's make a very quick summary. Okay, so now to be able to make a comparison between ionic and covalent compound, we must know that they are made of what they do with electrons. They exist as solid or liquid gas at room condition, which is 25 degrees Celsius. They are soluble or not in water or organic solvent. Alright, we must able to compare their melting and boiling points, and lastly we must add activity. Okay, so you should focus much more on the melting point, boiling point, as well as electric conductivity. That's why you can see a star over here, because for electric conductivity and melting point, you not only need to know how to do the comparison, you must be able to explain the differences. Okay, so now we can discuss a question or two before we end up with the chapter 5. Okay, so now theoretically you should have achieved all the outcome you need for these topics. Okay, alright, one or two questions to discuss, okay, to end up with this particular chapter. So you can refer back to page 22. Okay, you can refer back to page 22 in the exercise booklets. Okay, so page 22, question number 3. This is the questions that came out in SPM 2010. Alright, so now the question is actually asking you, alright, you are given x, y proton numbers. So first of all, they want us to write the electron arrangement for an ion Z. Be careful with the words atom and ion. So we start with atoms. So atom Y, so look at the Y. Y have 12 proton. So we know when atom Y is neutral or don't have any charge, the number of proton must be equivalent to number of electrons. So Y should have 12 electrons as 2, 8, and 2. Okay, so should be quite okay. Many students will make mistake, some careless mistake for the second one, which is the Z. So now look at the Z. So technically Z has 17 proton. Technically Z should have 17 electron. 17 electron by right, you should get 2, 8, and 7. By right, you should get 2, 8, and 7. If you put the 2, cause now they are not looking for atom Z, they are looking ion. Now let's think back, let's recall back. So what is ion? Alright, ions is something that got charged, and we know you will have charge when we donate or receive electrons. Okay, we will have charge when we do. Z have 7 valence electron. Alright, so ions, so you have 7 valence electrons. In order to be ion, in order to be stable, you need to receive one more, okay, to become Z minus ion. So after receive 1 electron, the arrangement now should be 2, 8, 8 instead of 2, 8, 7. So you have to be very careful with the wordings. Okay? They are looking for ion, they are not looking for atoms. Alright, now you need to write the formula for the compound that form between Y and Z. So when they say compound, right, Y and Z, so it's all boil back to the ionic and covalent bond. So we will follow back all the routine things that we discussed. Alright, first of all, you must able to predict they form ionic or covalent compound first. Okay, so look at your Y. atom Y, it's have 2A2. So 2 valence electron, put it in a group 2. So group 2 is a metal. So atom Z has 17 electron, which is 2A7. 7 outer electron, put it in a group 17. So group 17 make it a non-metal. So when we have a metal and non-metal, we know they will merge to form ionic bond or ionic compound. Alright? So after decide the bonds, now we can predict the formula. So we all learned before, if you want to predict the formula for ionic bond or ionic compound, we must know the charge. Okay, we must know the charge. So now from what we have on the screen, we don't have any charge with us at the moment. So we have to know how to predict the charge. So we will get charge, we will get ion if and only if we donate or receive electron. So let's start with Y. Y has 2 valence electron. Donating 2 electron is the easiest way to make it become stable or octet. So when you donated 2 electron, you become 2 positive. So Z has 7 out to be stable is receive extra 1 electron. When you receive electron, you become negative. So now we already know the charge for Y and Z. The Y is Y2 plus, the Z is Z minus. So now you refer back to the knowledge that you learned in your Form 4, Chapter 3. So when we have 2 ions with opposite and different charge, we should do a cross method. Okay, the 2 should go to the opposite side, the right hand side, and the 1 should go to opposite left hand side. So you have Y1 and Z2. So the final formula is Y, Z. So this is the formula. Alright, so you have to go back to the things that we learned in the beginning of topics. You must know exactly that substance is metal or non-metal. From there you can decide the type of the bond. Once you know the type of the bond, then only you can predict the formula in their way. Please be reminded again, for ionic compound, if we want to do the prediction of formula, we have to know their charge in the first place. But for covalent compound, we don't need to write the charge. Okay, we just need to write on top here the amount of it in order to be stable. Alright, so now let's move on. So now we come back, we know the answer. This one should be YZ2. Okay, alright, now we have 2 more sub questions to go. Alright, question number 3. Element X react with element Z to form a covalent compound. The formula is XZ4. So they clearly tell us we have a covalent compound, and the formula they told us as well, XZ4. So we have properties of this covalent compound. Alright, so 2 physical properties. You can refer back to the comparison we have just now. Alright, the comparison between the ionic and also the covalent compound. Okay, those are the comparison. Okay, such as this one. Okay, so these are some of the comparison. So there are many comparisons we can do, but normally there are 3 major ones. The first one is that you can either talk about you also can talk about melting, boiling point. You also can talk about solubility. Right. So let's start with melting and boiling point. So we know covalent compound has a low melting and also boiling point. Okay, low melting and boiling point for covalent substance. Alright, the second thing is solubility. So when you come to solubility, you must specify what are the solvent you want to use. The word soluble, or you cannot only write the word insoluble. That's not appropriate, because you have to understand that there are 2 big family of solvents. So if you only say soluble, examiner will not understand that the soluble means you soluble in what kind of solvent. So you must mention the solvent. Do remember the 2 family of solvent, it's water and also, right? So if we refer back to our list, so covalent compound, alright, covalent compound. If you talk about solubility, water, they are insoluble, but organic solvent, they are soluble. So you can write this. So you can either write soluble in organic solvent. Alright, or you can write insoluble. You don't need to write both, okay? You just write either one, you will get your. Now I'm asking, can we actually write like these 2 points? The first point I write soluble in organic solvent, and then the second point you write insoluble in water. No, you couldn't do that, because from the eyes of examiner, if you're talking about solubility, for them they are considered as one same properties. So although you write for 2 cases, one is you are not getting the marks, they only give you 1 mark. Alright, so last one. So for the last one, you need to draw the electrode arrangement for XZ4. So let's draw this electrode arrangement. So as what we discussed in previous part, so we know that when we come to the explanations, so when we come to the arrangement, we are talking about cross and dot diagram. Okay, they tell us that XZ4 is a covalent compound. So for covalent compound, you expect your picture must have overlapping, so you must have this kind of overlapping there. Alright, let's start with the picture, let's start with the drawing. So we want to draw XZ4. Let's get all the necessary informations. Let's look at the electron arrangement first. For X, from the booklets, okay, you have 6 electron, so which means that is 2 and a 4. For Z, you have 17 electrons, so which is 2, 8 and 7. Okay, we all learned before that if you only have 2 substance, one X and one Z, so by right they should be next to each other. Like here, this is one X, this is one Z. But this is not the case, because we have more than 2. We have total 5 atoms. We have 1 X and total 4 Z. So there are total 5 atoms. So when we have more than 2 atoms, we must always put the one with the smaller quantity in the middle. So the X must put in the middle, sandwiched by 4 other atoms. Z, from Z is here, Z is here, Z is here, Z is here. Alright, so this is what you should do on the placement of atoms. After that, you can start with drawing the circles. Okay, you draw a circle, keep it big first. Okay, so please remember, you have to make sure that your circle has a region that's overlap. You must have an overlapping. So why we need overlap? Because XZ4 is covalent compound. For covalent compound, there is a sharing of electron. When you want to share the electron, there is a overlapping. Alright, so we never know how much electron they are sharing when it comes to covalent compound. So it's all about try and error. So we always try with sharing 1 electron first. So please just assume Z should put 1 electron for sharing, will also follow the same thing, because remember, when it comes to sharing electron, they must be fair and square. Alright, so party A share how many electron, party B must make the same contribution to share the same amount of electron as well. So same thing go for here. The Z dump in an electron for sharing, X will follow the same. The Z put in 1 electron for sharing, X will follow the same. The Z put 1 electron for sharing, Z will follow the same. Okay, so after you put 1 electron for sharing, now you have to draw the outer electron. Alright, so outer electron, because do remember, sometimes they have some electrons that is left over that they don't put in for sharing. So you can start with X first, maybe. Look at the X, 4 valence electron. So when you have 4 valence electron, you have 4 outer electron, and these 4 outer electron, you put 1 here, 1 here, 1 here, and 1 here. So all the 4 electrons already being utilized. You use all the 4 electrons already, which means outside here, there's no more leftover electrons. What about Z? Z has 7 valence electron. So in the outer shell, you should have 7 electrons. So we choose the Z to start. Let's say for this Z only contributing 1 electron for sharing. The Z contributing 1 electron for sharing. So when you contribute 1, which means that you have 6 more electrons left over. So we put 6 more outside. 1, 2. Do the same thing for all the Z, because they are exactly identical. So let's do this. So after you put all these outer electrons, now you have to ask yourself a simple questions. After they contributed to 1 electron for sharing, is it what they want? Are they stable? So you start with Z. For Z, as you can see, you have 2, 4, 6, and 8 electrons. So you got 8 electrons after sharing. That's a good one. So look at the X. So the X now have 2, 4, 6, and 8. So X also have 8 electrons, so X also stable, which means that this is the diagram that we want. Because do remember, the ultimate objective for learning this chapter, we want to form chemical bond for one simple reason. They want to be stable. Okay? So after everything is complete, after stable, please do not forget to draw the inner shell. You're not done yet, because the X by right should be 2 and 4. There should be 2 circles. We only draw the outer circles. So there's one more circle inside. So this is 2. So you draw a small circles, and then you put 2 electrons inside here. For the Z, you have 3 circles. You have 3 shells. 2, 8, 7. So you have 2 more circles inside. So you draw 2 more circles inside, which is alright, which is 2 and 8. 2 and 8. Okay, so this is the diagrams. Okay, so when you draw, it's advisable you don't draw the inner circle first, because if you draw all these inner circles one shot, there are too many circles, it's very confusing. So for me, I will always draw I'll try to share 1 electron, and I see after share 1 electron, are they stable or not? If not stable, I will increase the amount to share 2 electrons, and so on. So once everything is stable, then only I draw the inner circles. Alright? And that's the end of chapter 5. Okay, so before we finish with this video, so we can do another one more last additional questions. Alright, so we can look at the exercise booklet, page 23. Okay, this is page 23, the exercise booklet. Okay, so now let's look at it. Table 4.2 show you some physical properties of 2 compounds. One is U, one is V. Alright, so you're given the compound UV, the melting point, their boiling point, the solubility in water, as well as organic solvent. Right, so from here, even they don't tell us, but we can make a simple guess, as you can see here. Right, compound U, melting point pretty high, boiling point very high, soluble in water, alright, insoluble in organic solvent, even they don't ionic compound. Alright, for compound V, melting point very low, boiling point quite low as well in compared to this. Insoluble in water but soluble in organic solvent. I think it is a covalent compound. Alright, now the question wants us to predict the physical states. Remember, when they say physical states, means they're asking you it is solid, liquid, or gas. So at room temperature is 25 degrees Celsius. So this one is not very hard. We all learned this before in chapter 2. You can use a 3 lines method to do the predictions. So let's U. So U, if you look at the 3 lines method, solid, liquid, and gas. The melting point is 800. Your boiling point is 1420. Just is below 800 is here. So it is a solid. So if you look at the V, if you draw the 3 line, this is the melting point minus 95, the boiling point 86. This is solid, liquid, and gas. The temperature that we want, room temperature 25. 25 is more than negative 95. 25 is less than 86. So it is in this particular region. So it is. So that's what we need to know. Okay. So now we can look at the last questions. So this is a very good question. This is a very good question. This is a K-BAT, or we call it a HOTS questions. This is a higher order thinking questions. Very interesting. So the question say table 2 shows the proton number and nuclear number for element X and Y. So X and Y are not the actual. Alright. So you are given the X and Y and their nucleon number. Question say X and Y react to form compound. So it must be ionic or covalent. What is the molar mass of the compound? Molar mass also means RAM, relative mass. So what you should do with this? So first of all, we not even know what is the formula for the compound between X combined with Y. I not even know that. So we have to compound, just like what we did before. To predict the formula for compound, we need to understand they are metal or non-metal. This can be done by knowing their group number. So let's kickstart. So we will start with writing their electron arrangement. X has 13 protons, so 13 electron, which is 283. 283 is in group 13, which I know it is a metals. Alright, so substance Y has 8 electrons. So I have 2.6. So when I have 6 outer electron, this put it in 16. So group 16 is a non-metal. So when we have a metal and non-metal, you know they will get ionic compound. So to get ionic compound, we must able to predict the formula. To predict the formula for ionic compound, we need to know the charge. So let's predict the charge. So X has 3 outer electrons. Stable is donating 3 electrons, so you become 3 plus. Y has 2 electrons, so the easiest way to be stable is receiving 2 electrons become 2 minus. So once we know the charge X3 plus and Y2 minus, we can exchange a number. 3 go to here, 2 comes to here. So I know the final formula is X2. So this is the final formula. Alright, so now we know the formula, we can calculate the molar mass. So molar mass means that the mass for your substance. So if you want to know the mass of substance, you have to know a simple thing. Alright, normally they will give us the mass of substance in the form of RAM, but in this question they are not giving to us. So how are we going to do? Okay, your RAM is your nuclear number. Why? In nuclear number is the total proton and neutron. So in one atoms we have proton, neutron and electrons, but electron, the mass is very small, okay, in compared to proton and neutron. So that's why the mass of electron is always negligible. So when we want to know the mass of one atom, amount of proton and neutron, so the nuclear number will be actually our RAM. The RAM, also called the mass for our atoms. So the X, the mass is 27. So we have 2x here, so 27 multiplied by 2. The Y, the mass is 16, so we have total 3 of it here. Okay, so this whole thing, if you add together, that's answer go for C. Alright, so then of your chapter 5, okay? And the end of this particular video.